Big project with an artist. Come on in. Welcome to Maker's Digest. Today we're going to review a project that I've been working on for the last few weeks. Turned out to be a pretty big one. We have wood fabrication, 3D printing, electronics, programming, and art. I was teamed up with a local artist here in Sacramento by a creative agency called Hiker. They were putting on an event called Artists and Engineers by Verizon. There were 6 pairs of artists and engineers that were to build something of their own choosing based on a few categories that they gave us. I was paired up with Bryan Valenzuala, a local artist who does work all over the place. Check out his work at his website, linked in the description. The sound you're going to hear in the background is the music we had playing over the PA throughout the entire event. I talk a little bit about it later in the video, so let's jump in and take a look. Our intent was to build a lightbox with multiple layers of etched acrylic, a bottom layer of sign white for diffusion, and a top layer with the hands painted onto it. The size of the box was to be 4 foot by 2 foot and approximately 8 inches deep. The depth of the box let us stack all of the layers of acrylic and have room for the LEDs to diffuse properly. The lid for the piece was to be opened by the viewer, and then it would start its programming of the LEDs. I was going to use a unipolar Hall effect sensor for this. On the inside of the lid, we wanted to put a mirror. For the lights, we wanted to have a lot of control over individual LEDs. I ended up setting it up with 16 channels of WS2812B RGB LEDs. For the box itself, we wanted to go with 1/2 inch MDF. It cuts super clean and accepts the laminate well. All the joints were glued with Titebond 2 and brad nailed together using 1-inch brads. After the assembly of the box and the glue was done curing, I sanded each of the edges to prepare it for laminate. This was probably the easiest part of the entire build. We wanted to have the box be black, so we used black formica laminate for the entire outside of the box. This stuff is available locally and extremely inexpensive. It comes in a large roll that's about 4 foot by 8 foot. It's a bit larger than that, so you have room to trim. It's easy to cut with a razor knife to get it into manageable sizes. Once it's in a manageable size, it cuts easily on the table saw. You always want to cut your laminate oversized for the surface you're applying to. In the end, we'll use an edging bit on a router to clean it up and make it all flush. The method I use to apply the laminate is pretty simple. I prepare both surfaces by sanding the substrate and then cleaning both substrate and the laminate with compressed air and wiping it down with a rag. I then apply a coat of weldwood contact cement using a roller. This helps get the coats even across both surfaces. The edges of the MDF soak up a lot of glue, so you have to apply a couple of coats to the edges to get enough on there. I let the contact cement cure for about 10 minutes or so until it's tacky. Then I put dowels or sticks down on the substrate surfaces so that when you lay the laminate down, it's not touching the substrate. This allows me to line up the laminate with the substrate surface. Once those two parts touch with the contact cement, they are bonded. You want to pay close attention to make sure that you get this lined up right the first time. I usually do this by touch. I feel around the edges with both hands and make sure it's got an even overhang on all sides. Once that's done, I pull out the first stick and let the laminate touch the substrate. I press a small strip down by hand to get an initial bond. That way it won't shift around when I pull out each subsequent stick. I use my J-roller to roll the laminate on. This makes sure that the surfaces are all bonded and gets rid of any air bubbles that may exist. Keep doing this down the length of the laminate. Pull a stick, roll it on until all the sticks have been pulled. And the glue is nasty. Make sure you have plenty of ventilation and use a rated filtration mask. The next step is to flush route all of the edges of the laminate. Once it's dried, I get out the router and set up my flush cut bit. I route all the edges to flush the laminate with the substrate. I usually keep the bit as high as possible so that if there's any wobble in my hand routing, it does not mar the laminate on the edge. I decided to set up the LEDs in a radiating pattern from the center. The math turned out to give me 16 strips in total. I experimented with different diffusion distances from the LEDs to the sign white. With the depth of the box, I could have a maximum of 4 inches from the bottom of the diffuser to the bottom of the box. Turned out the best placement was the full 4 inches. But then we were getting some shadows from the LEDs when they were near some of the components that were inside. The power supply was the tallest component, and it was about 1.5 inches tall. I figured that if I raised the LEDs up by 1 inch, we weren't going to get any shadows. Of course, we tested that, and it was true. To raise it up that 1 inch, I would use 1/2 inch MDF on edge. Whenever I apply these WS-2812s using the adhesive that comes with it, I always like to back it with some kind of mechanical fastener. In this case, I wanted to use zip ties. I measured the distance between each LED on the strip and built a jig to drill a small hole with that spacing so that my zip ties always landed in between the LEDs. I also needed channels under the strips of MDF for routing wires once they were glued down. For that, I modified the jig to drill larger holes on the bottom of the MDF strips so that it penetrated the bottom side. Each of these strips were glued down with Titebond 2 and brad nailed. There's quite a few LEDs in here. Each LED at full brightness will draw 60 milliamps. I estimated height with 2 feet of LEDs per channel, giving me 33 LEDs on the longest strip. Of course, some of those strips are shorter than that, giving me less LEDs. But that's what I based my power requirements off of. I figured that would give me plenty of overhead for the power supply. The math was 33 LEDs per strip, times 16 strips equals 528 LEDs. 528 LEDs times 60 milliamps came out to 31 amps total at 5 volts. With the actual amount of LEDs much lower than that, I could get away with a 30 amp power supply. I bought some beefy bus bars for the power distribution and separated all the power leads from the logic leads coming from the LEDs to the Arduino. I also set up power from the power supply to the Arduino so it didn't have to pull it from USB. I had originally planned to use a Teensy, but didn't check before I bought it, and its logic runs at 3.3 volts, which doesn't work so well for the LEDs that I had. I didn't have time to either buy a level shifter or build one, so I just grabbed an Arduino Mega, which does run at 5 volts. I put a 330 ohm resistor on the LED side of the logic lead, then ran the wires back directly to the Mega. I had planned to build a shield for this thing, using screw terminals with the resistors on it, but I realized that I wanted to have the resistor as close to the LEDs as possible. I ended up just tinning the 22 gauge wire and plugging it directly into the Arduino. Once I was all done with testing, and I mean all done with testing, I globbed on some hot glue to hold all the wires in place on the Arduino. There were a few times where I ran out of resistors or had the wrong Hall effect sensor or something like that. My buddies over at Maker HQ, which is in the same building as the shop, were able to help me out since they just happened to have all the parts I was missing in stock. Maker HQ is an awesome makerspace in Sacramento. Check them out at makerhq.org. I'll put a link in the description. To get power into the box, I cut a large hole in the back, 3D printed a plate that would hold a power connector with a switch, as well as a USB port so I didn't have to open up the whole thing to flash new code. While all of this fabrication was happening, we had our etching going on the laser cutter. We etched 6 2-foot by 4-foot surfaces. Each one took from 5 hours to 7.5 hours. Bryan created the entire piece in Photoshop, exported it as a full-size JPEG for each layer. We then imported it into the laser software to get it ready for the etch. Before we did any of that, we used some of the exact material that we were going to use to test with. We ran 6 or 8 passes with different speeds and different power settings. I wanted it to go as fast as possible with the right penetration. Ended up being about 300 millimeters per second. These came out amazing. We left the paper on it so the acrylic didn't get the small amount of heat damage it takes while the cut head is moving as fast as it does, and also to protect it from scratches. That meant that we had to remove all of that paper after it was etched. Bryan volunteered to do this part at his studio. He had an intern assist him through that process. From what he tells me, it was a real pain. There were very tiny bits of paper and some of the lettering that they used needles to pry it out with. It's an amazing amount of work that they put into that. An amazing job cleaning all the edges by both of those guys. Before we laminated the box, we wanted to paint the inside edges so that you could see through the clear acrylic. We did about 4 or 5 layers from a rattle can that was a combination paint and primer directly on the MDF. One of the last things that I wanted to do was put the felt around the edges. Bryan found some felt that had an adhesive backing on one side. I had to cut it to size and then roll it onto each of the edges. Not a bad process, but it did take a couple of hours. Bryan hand painted the hands onto the top layer of acrylic. If you look close, the hands are all text. The level of skill and time he put into that amazes me. This is just another level. Bryan also painted a huge mural on canvas that we could roll up. This ended up being the backdrop for the presentation. With 4 days to go until the show, we took the completed box to Bryan's studio where it's clean. He had that place virtually free of dust. I couldn't keep dust off this thing for 20 seconds in my empire of dirt. We had all the cleaned up acrylic sheets and were ready to stack them. We put a 3/16 square acrylic rod in between each sheet so that there would be some separation to give it depth. Once that was complete, we moved the unit to the Maker's Digest studio around midnight that night. All of the fabrication was done, and now it was time to code. I spent a good half a day testing different LED libraries and finally settled on the Adafruit NeoPixel library, since it was the fastest one. Once I had that selected, I thought about how the animations were going to work and wrote a library of my own to manage the LEDs for this particular setup. I'm glad I did that because it let me code pretty fast through the rest of it. We were trying to simulate the life cycle of a black hole, so I basically knew what I wanted to do. Once I got a part of the animation done, I would shoot a quick video and text it to Bryan for review. He would have some feedback, I would modify it, and then we would iterate again until we were both happy. We finally got to a place where it was done. It was ready to install. I finished a day early and got a day off. For the presentation, we wanted to have some audio. Bryan took a song, I'm not sure which one, and we probably wouldn't say anyways, and stretched it out to like 5 hours. Copied that over to another track and reversed it. He sent all this to me for mastering. I cleaned it up, beefed up the low end on it, and exported it as an MP3. I brought one of my small PA systems to the event, and it played through that all night. It took 3 trips to get all of our gear to the venue. Once it was all there, we spent several hours hanging the mural, setting up incandescent uplighting for the mural, setting up audio, and finally placing the black box on the rug and cleaning it. The event was the next day. It was on March 9th, 2019. From 4:30 to 5:30, there was a VIP event where the Sacramento mayor spoke about art and technology in the city. Once that was over, it was general admission for the rest of the night. A bunch of my maker friends came out to see the completed project. The event was at a makerspace in Sacramento called Hacker Lab. They had just moved into this new space. Bryan and I stayed throughout the whole show talking to all sorts of folks about the project. Art enthusiasts to engineers and makers. They all had their specific questions and we did the best we could to answer all of them. It was a great turnout. I'd guess a few hundred people cycled through during the entire event. Well, there you have it, completed black box project. One of the things that I learned throughout this process that is awesome working with an artist. I've worked with other types of artists, graphic designers, industrial designers, architects, whatever, but Bryan is amazing. His level of detail is just different than mine. I wouldn't say he pays more attention to detail, it's just different. Things that I would say are okay and done because they are, and it's good, he wanted to go back over and work it out. We really had a great team. Thanks to Bryan for creating amazing art and enduring a new perspective and materials that I brought. Thanks to Romeo, who was Bryan's intern. He painstakingly cleaned each one of those acrylic sheets and helped us with the setup at Hacker Lab. Thanks to Kara, Francesca, and Gregor at creative agency Hiker for setting up the event, and thanks to Verizon for making it all possible. I hope you're inspired by this project to go out and make something for yourself. Find an artist and work with them. It was an awesome experience. And stick around, the whole animation will play after this clip. If you like this video, please consider subscribing and ring the bell so you get notified when a new episode is available. Thanks for watching, and until next time, keep making.